Hello class, I hope this video finds you well. Today we're going to take a look at the model all put together and see how we can use that model to understand what happens to us in storms when they happen. So if you've got your storm model out, you want to make sure that you've got it all caught up. It should look something like this. Okay, at this point, our storm model started off with the snow-covered land and the dark-colored land, and that caused some differences in temperature. The light would hit, the sunlight comes down, it hits the dark soil like farmland down in southern Illinois, and it gets absorbed. It turns into heat, and it hits snow-covered land like what's up in Canada right now still, and reflects off. And then so we've got some warm ground and some cold ground, and so the air above the warm ground gets heated, but the air above the snow-covered land doesn't. And so we end up with two air masses, two sets of air that are very different temperatures, one warm, one cold. And then we know that warm air rises and cold air sinks, so that causes the warm air to go up, causes updrafts, causes the cold air to sink, causing downdrafts, and then that creates areas of high and low pressure. And it also creates some surface winds and some upper winds, which are going in opposite directions. When the warm air rises and loses pressure, that's when we get clouds forming. Okay, and that's what's creating our clouds and our thunderstorms. But what the model doesn't show you is that this is just the border between the warm and the cold air. There's actually a long amount of cold air and warm air on either side of this that we're not showing. The other thing the model doesn't show is that this line, this boundary between the cold and the warm air that we call a front can move. And so even after the warm airs and cold air form, they can drift and move past us. So even if we're standing still, we'll experience changes in temperature. Sometimes we're standing in the cool air and there's warm air that moves in, and that causes rain. We call this a warm front. Warm fronts tend to be long, slow, drizzly rain, and we're usually standing in cold air when it's happening, so that happens on cool days. And then we usually end up with some warmer weather afterwards. The opposite, though, when we're in the warm air and the cold air comes in, this is called a cold front. And this is what thunderstorms are usually caused by, is when we have a warm, humid day. It's sunny, it's hot out, it gets humid, you start to see a little bit of clouds form, and then very suddenly you feel the temperature change. It gets cold. And the wind picks up. And then all of a sudden it rains very hard on us. And then it ends very quickly. And we end up with a nice, cool, dry day afterwards. That's called a cold front. And this is what causes thunderstorms. This is when that comes through, it usually comes through very fast. And we might even see thunder and lightning and hail and even tornadoes sometimes when we have that cold front come in. So our next lab, what you're going to be doing is you're going to be taking our model and thinking about what I just showed you and looking at some specific storms that have happened right here in Arlington Heights and seeing if that didn't follow the pattern that we saw with the cold front, where the temperature drops and then the wind picks up and then the rain starts and gets very heavy, and then it clears up afterwards. We'll take a look at some specific storms. I think some of them you might even remember.